Good morning. This lesson is for my Integrated 1 honors class, but before I get started, I want to say I hope that everybody is doing okay out there. Let's go ahead and jump right in. This is for section 14.1, and this is an introduction to geometric sequences. So our first goal is going to be to define geometric sequences and the common ratio, and then our second goal is going to be to extend geometric sequences. This lesson is probably going to seem very familiar, like we've kind of already done this before, and you kind of already have. So let's jump into our first goal here. Last semester, our patterns used addition and subtraction. We called these arithmetic sequences. Geometric sequences are patterns that use multiplication and division. I put an asterisk right here. We tend not to use division. We tend to multiply by the reciprocal. It's the same thing, but you can use division. It's just a little harder to plug into calculators as division. But anyways, in arithmetic sequences, the change in consecutive terms is a common difference. In geometric sequences, the change in consecutive terms is a common ratio. Now, common ratio is a real fancy way that people say the word fraction. So there's a common fraction. So I have two examples here of tables that grow in a sequential order, 1, 2, 3, 1, 2, 3. You know, and we'll see later on that these numbers can be actually spaced out, not start at 1. We'll see again, like we saw last semester with arithmetic. That this will grow and change. So we have a background in this. So we're this is kind of like a review lesson, but we're using multiplication now and division. All right, so this table, 5 turns into 10 by adding 5. 10 turns into 20 by adding 10. This is not arithmetic. I do not have a common difference. However, 5 turns into 10 by multiplying by 2. 10 turns into 20 by multiplying by 2. And in fact, if I write the second term being divided by the first term, which is a common ratio, so 10 over 5, that is 2. And for the third term, we would take that and divide that by the second term, and we'd get 2 as well. So this table does in fact have a common ratio, and I need to make this very clear. The common ratio is the fraction is the next term divided by the previous. Okay, so the next divided by the previous, the next divided by the previous. So this would be a geometric. I have a pattern that's multiplication based. 5 turns into 10 by multiplying by 2. 10 turns into 20 by multiplying by 2. Let's look at the next table. This is not arithmetic because I can't take away 66 from 99 and get 33, and then take away 66 again and get 11. So this is definitely not arithmetic because I don't have a common difference. However, if I set up my ratio as the next over the previous, you will see that you can actually divide the numerator and the denominator by, what can I divide that by? The largest number I can divide that by is actually 33. So this is going to reduce down to 1/3. To go from 33 to 11, I'll find my common ratio, or my ratio, and that would be my next, which is 11. Divide that by 33. I can divide both of these by numbers. I can divide both of these numbers by 11 and get 1/3. So again, this is geometric. I have a common ratio. Now, I'm dividing by 3, but remember, I mentioned that we don't really say division. We multiply by the reciprocal. So instead of dividing by 3, I multiply by 1/3. So those, I'm going to go ahead and check off our first goal here. And I'm going to move on to the second goal, which is to extend geometric sequences. So let's look at this first table. All right, I know that the first term is 5, the second term is 10, the third term is 20. I can find the fourth and the fifth and the sixth, right? So I know that the fourth term is going to be twice that. So that's going to be 40. I know that the fifth term is going to be twice this. So that's going to be 80. And I'll do one more. I know that the sixth term is going to be 160. Because again, I have a common ratio and it's telling me that consecutive terms are changing by a doubling by 2. So that would be me extending the geometric sequence. All right, let's extend this one. All right, so I know that I am multiplying by a third. Now, just a quick review in fractions. If I have a fraction a over b, and I'm going to multiply it by a fraction of c over d, I just multiply it straight across, and I get a times c divided by b times d. All right, so I know to go from 99 to 33, I have to multiply by a third. To go from 33 to 11, I have to multiply by a third. So to find the next term, I'm going to multiply this by a third. So I have, I'll just do a little scratch work off to the side. I have 11, which becomes 11 over 1 times a third. And this is going to give me 11 times 1 is 11. And 1 times 3 is a third. All right, I want to find the next term. So what I'm going to do is I'm going to multiply this by a third. So again, 11, I'm probably off the board. 11 over 3 times 1 over 3. 11 times 1 is 11. 3 times 3 is 9. So I am extending the geometric sequence by multiplying the next term by the common ratio. So hopefully this makes sense. This is all the tools you need for the homework assignment. And again, remember, geometric sequences use patterns of multiplication and division. And once we know the common ratio, we can extend the table. That's all we need to know how to do for today's lesson. So again, I hope everyone's doing all right out there. Have a good day. Have a good day, everybody. Bye-bye.